Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning, everyone. Can you hear me?
Yes, sir.
Right. We proceed to the slide number 14. Okay, where you are given a transfer function. Previously, was K where K equal to 1. Okay, so we plot plus 1. Okay, so we have the open loop poles, which is 0, okay, and minus 10. Okay, then we plot on S-plane, where this is the real axis, and this one is the imaginary axis. Okay. For your information, please remember that this line, okay, is the zeta line, or we call it as a damping ratio line. And the circle line is the omega n, which is undamped natural frequency. And the imaginary axis is g omega. Okay. So the root locus will be plotted, okay, as shown in this plot, okay, where you have a lot of closed loop poles, okay. And then another one from minus 10. Okay. And this one is minus 5. Minus 5 is the breakaway point. Okay. So the locus will be start from poles and ended at zeros or infinity. So remember, okay. root locus start from poles and ended at zeros or infinity. So now we have poles at 0. So you start from here. Okay, met at -5 and then go up towards infinity. And then the second one will start from -10. Okay. Then ended at -infinity. Okay. So each of these closed loop pole, okay, on the root locus have a varying k value. Okay. Meaning that each of the closed loop poles on the root locus have the different k value or gain value. So therefore, from the root locus that I discussed just now, we have a 3 range. Okay. The first one is k less than 25. So less than 25, meaning that the poles are real over them, and zeta is greater than 1. Okay. So meaning that it is located. Okay. I delete first. Okay. This area. Okay. Okay. This area is zeta greater than 1. Okay. Same.
Okay, I've found this on the web for this area, which is the greater than 1K. Check it out.
Right. Okay. And then the second range is k equal to 25, where the poles are real and multiple, or we call it as overlap. Okay. So it is located here. Okay, at -5, where zeta is equal to 1. Okay. We call it as critical dam. Then the third one is k greater than 25, and it is under dam, where the zeta is between 0 and 1, which is on this part. Okay. Where you can see that zeta greater than 1, or k greater than 25. Okay. Zeta equal to 1, k is equal to 25. Okay. So my concern actually is to tell you that the quadrant under concern is the quadrant that this one. Okay, this quadrant. Okay, where the controller that we design must make the system working in this quadrant, where zeta between 0 and 1. Okay. So where is zeta equal to 0? Zeta equal to 0. Sorry. This quadrant. Okay. Um, So this one is J omega. This one is real, eh? So it must be in this quadrant where zeta is between 0 and 1. This axis, okay, real axis is where zeta is equal to 1. And this axis, imaginary axis, zeta is equal to 0. Okay. So this one, zeta equal to 0. This one, zeta equal to 1. So our working area is in this one, between 0 and 1. The green line, okay, the green quadrant. Okay. So for the underdamped system, regardless of the gain value, any gain value, the real part are always the same. Okay. Real part tu adalah the minus zeta omega n axis. Okay. Real axis. Thus, the settling time is remain the same. Okay. Meaning that we learned already the formula for settling time, 4 divided by zeta omega n, which is modulus lah, positive value. Even though the value is negative, we take the modulus value. So since any gain value, the real part is always the same. So 4 divided by zeta omega n, you divide by the same numbers, it will give you the same settling time. So since the root locus never cross into the right half plane, okay, this is plane P, L, A, and E. The system is always stable for all value of K. So once it goes across the right half plane, so the system is not stable. Therefore, root locus is useful for higher order system analysis, okay, for stability. So the question is, can we draw a root locus for higher order system? The answer is yes. Okay. Properties of the root locus will be helpful to sketch root locus for higher order system by considering closed loop system with the feedback here. Okay, so this is the closed loop transfer function. Okay, if h s equal to 1, so this will be unity. Okay, so a pole of s exists when the characteristic polynomial denominator becomes 0, or KGSHS is equal to -1, where this is the magnitude and this part is the phase angle. Okay, where K is 0, 1, 2, and so on. Alternatively, we can write it as magnitude modulus KGSHS is equal to 1. So please remember this formula. Okay, and angle is angle KGSHS is equal to 2K plus 1, 180 degrees, where K is equal to 0, positive, -1, positive, -2, and so on. So thus, a pole of the closed loop system cause the angle of the KGSHS to be an odd multiple 180. Odd meaning number 1, 3, 5, and so on. So the magnitude of KGSHS must be unity. So from equation 1, if we take out K outside and we bring GSHS to the right, so you will get the gain formula, which is 1 over GSHS, magnitude of GS and HS. So from the previous example, the table here, to plot the transfer function root locus just now, which is the K S square plus 10S plus K. You can see that when we varying the K, you will get a closed loop pole 1, closed loop pole 2. Okay. At 25, it will give you same pole value overlap, -5 and -5. Okay. Then after that, the pole's nature become complex conjugate pole. Complex conjugate pole. Okay. So by substituting the pole, S is equal to -9.47 here, okay, and K equal to 5. So you will get KGS is equal to -1, meaning that it satisfies the gain criteria. Okay? And all closed loop poles must fulfill this requirement, because if the closed loop poles didn't satisfy KGS is equal to -1, meaning that the closed loop poles is not on the root locus, and it's not the point of the root locus. Let us see this example where you are given a closed loop system. R is the input, and CS is the output. Okay. And you are given a unity feedback. Okay. H is equal to 1. And here you are, the transfer function. Okay, the open loop transfer function. So may I ask somebody from the class? Afik, are you there, Afik?
It's there.
Afik,
Yeah.
louder, can't hear you. What is the value of open loop zeros here?
Negative. Oh, -1
No,
and -2.
zero. Open loop zeros.
Open loop zeros. Oh, -3 and -4.
-3. What is the value of open loop poles?
-1, -2.
-1 and -2. So you are given 1 point, test point, which is -2 plus J3, closed loop pole value. Check whether this point is on the root locus or not. So in order to make this -2 plus J3 is on the root locus, it must satisfy the angle and gain criteria. Okay. So we check. First, we draw the locus. So this is -4. This is -3. Guys, can you follow me? This is -1, and this is -2. So as I told you before, a root locus start from poles and ended at zeros or infinity. Okay, so in this case, we have two poles. Okay, so we have a blue one. Okay, blue. Yeah. Then it goes up, ended here. And then the green one. Okay, yeah, here, go down, ended here. Okay. So bear in mind, we have two breakpoint, which is over here and over here. This one is breakaway point, and this one is the break-in point. Breakaway, break-in. So what is the difference? Breakaway occurred between two poles. Okay, you have two poles. Okay, so and the flow of the root locus is going out. Okay, but for break-in point, it occurred between two zeros. Okay, -4 and -3, and the flow is going in. Okay, going in. Both are break point, but one is away, one is in. Okay. So our task now is to check whether this point -2 plus J3 is on the root locus or not. Okay, so we draw a line, -4 and -3 zeros. We draw a line. Okay, this one L1, L2, and then from open loop poles -2 and -1, we draw a line towards -2 plus J3, the test point. Okay. Then we measure the angle. Angle of θ1, θ2, θ3, and θ4. Li Zishan, are you there? Li Zishan,
Yes, sir.
how are you?
Doing great.
Okay. How you measure θ1? This is 3 because of J3. This is 2. And this is L1. How you measure θ1?
Tangent θ1 equals to 3/2. So shift tangent 3/2. You get the theta.
What is the angle? What is the angle? Calculator, please.
Uh, 0.625 radian.
Angle, degree.
Oh,
Hmm.
35.78 degree.
Arctangent 3/2. Are you sure? Are you sure? Arctangent 3/2. This one kan? Lee.
Yeah. Should be 56.31.
And L1, the length of L1. Berapa? Somebody help?
$3.61.
Good. And then for θ2, Abu Bakar Halim. Abu Bakar Halim.
Yes, doctor.
θ2, please. Angle. correct?
Yes, 71.5.
L2, the length.
2.
Huh?
2.
2.
Yes.
Square root 10.
Sorry. Square root of 10.
First of all, huh? Square root 10.
Yes.
Kam hadha? Berapa?
3.16.
3.16.
16.
Syukran. Theta 3 is 90 degrees. Okay. Theta 3 is 90 degrees. And theta 4. Mushfiq. Theta 4. Mushfiq. Radam. Absent. Haziq. Mushfiq, are you there?
56.31.
Huh?
56.31.
Okay. And then theta 4. Kam hadha?
123.
100.
23.69.
Okay. Just now, L3. Sorry. L3 is 3. L4.
3.61.
Thank you very much. Okay. So now we insert inside. So the formula said the total angle of zeros minus the total angle of poles. So for the zeros is 56.31, 71.57. So minus 90 degrees due to the zeros, minus 108.43 degrees due to zeros as well. And the total is minus 70.55, which is not equal 180 degrees. Automatically, minus 2 plus J3 is not a closed loop for any gain. Okay, not satisfied angle criteria. So if not satisfied with angle criteria, so no point to use gain criteria. Okay, firstly, it's not fulfilled. So minus 2 plus J3 is not the root locus point. We try another point, which is minus 2 plus J square root 2 divided by 2. 0.707. Okay. Okay. By computer, we check minus 2 plus J 0.707 is located on the root locus. By computer lah, simulation. So, we evaluate, okay, this one. We repeat again. Okay, we repeat again the process just now. Okay, so in this case, just right here, theta 1, how much? Theta 1 is arctangent 0.707 divided by 2. Am I right, guys? Hello?
Yes, sir.
You sleep in my class, ayo. Okay.
Yes.
Arctangent 0.707 divided by 1. Okay, so theta 3 is 90 degrees. Okay, so theta 4 you calculate just like just now. Okay, and it happens that the total is the angle is 180 degrees. It satisfied the angle criteria. Okay. Then we calculate the gain K. Okay, the gain K. So you will get 0.33. Okay, by using theorem Pythagoras, L3 divided by L4 or L1 divided by L2. L3 and L4 due to the poles, and L1 and L2 due to the zeros. Okay, or you can calculate like this, or K is equal to S plus 1, S plus 2, S plus 3, S plus 4. Then you replace with minus 2 plus J 0.707. Okay, you replace this S inside this magnitude formula. Okay, do you understand how to do it? Hello, do you understand? Using calculator. This is another way to calculate the gain. Okay.
Doctor, the value 1234, is it fixed or based on question?
Value 1, 2, 3, 4 is given in is the open loop poles and open loop zeros just now that I mentioned to you. Ni. Ni. Kan daripada ni given kan. Is
Yes,
given.
Doctor.
Okay, clear?
Clear,
Clear?
Doctor.
Okay. Minus 2 plus J 0.707 plus 1. So if you use calculator, okay, you will get the answer which is same like my notes, okay, which is 0.33. You can check later. If not the same, you WhatsApp me. Okay. This is another way. I think this way is much better compared to the theorem Pythagoras using L1, L2, L3, and L4. So to check the point, this one is not satisfied. Okay, not satisfied. This one satisfied. You also can use MATLAB coding. Okay, to check. For example, here this is the test point that not on the root locus. Right, G theta is for the angle, M is for the magnitude, and K is for the gain. So you will get that this one not satisfied, but this one satisfied on the root locus, which is theta-nya is 179.99, which is 180 degrees. Okay. So remember that this is the formula for the angle. Summation of zero angles minus summation of full angle and magnitude. Okay, just now. And then the theta. The same as I mentioned just now. So far, any question?
Yes, sir.
Hmm.
The first question is the meaning that examine whether the certain point is a closed loop pole means that if let's say it's not a closed loop pole means it's not exist on the root locus.
Yeah,
Is it like it's not on the root locus?
point. It's not the point of the root locus.
Oh, okay, understood. And another thing is actually according to this example, the root locus you can see it's from the poles of 2 and then travel to the 3 using the half upper semicircle that travel using that route.
Yeah.
But how do I really know that it's using that path? Why can't the 2 and then travel using the green bottom one go to 3 instead of the upper one? Like if let's say we are doing example, how do we sketch it straight away. Oh, I see the equation. Oh, then I know it's travel using this.
Yeah. Meaning that how to produce and draw the plotting.
Yeah.
So it's
Or
actually it's based on the rule of root locus. But for your information, in this subject, you are not required to draw the root locus. The root locus is given.
so means that the root locus I already know that
The plot is given.
okay. Then I don't have to bother
No, you
use
don't
with
have to
routes.
listen.
Okay, I just have to know. Oh, okay, this one is it exists on the root locus or not like this? Okay.
If you see the past year test 1, test 2, and past year exam question, mostly the root locus is given. Okay, so you just analyze it. Okay, analyze it, find that, find this, and so on. But sometimes they ask you to freehand draw the root locus. Freehand draw meaning you don't have to use graph to draw the root locus, just a freehand draw. But that one is just 1 or 2 marks only. They want to see the test your idea that you understand or not the 11 rules of root locus, which will be in the next.
Because I saw that the more bottom of the slides it shows like using the rules, and then we need to find the angle of asymptotes, all those things and so on. So that one you mean that section will just cost maybe 1 to 2 mark?
No, if the question asks you to
sketch
or the root locus, or you just using a freehand drawing.
Okay. Kalau freehand drawing pun 1-2 markah saja.
Maybe 1, 2, 3 marks.
Okay.
Right, if there is no question, we move to the next example, slide number 27. So now you're given a open loop transfer function. Okay, which is this one, s plus 2, s squared plus 4s plus 13. Okay, and if you factorize this one, you will get a complex number. My question is, Shah Ikhwan,
Yes, sir.
open loop zeros, please. Value.
-2.
Open loop poles, please. Open loop poles.
-2 plus 3 plus minus 3
Plus minus G3.
G3.
Okay. So we plot it. Okay, here. So this is the point. -2 zeros. This one is -2 plus G3. Okay. And each of it have, sorry. Each of it have the angle, theta 1, corresponding angle theta 2 and theta 3. Okay. And this is what? This is the test point. -3. And determine if -3 is on the root locus or not. If is on the root locus, find the gain K. Okay. So we measure the angle, theta 1, theta 2, and theta 3. Okay. So if you look here, theta 1, this is theta 1. Okay, 180 degrees positive because of the zeros. Okay. And theta 2, which is this one. Okay. Theta 2 is 108.5. Okay. 108.5. And theta 3 is here. Okay, 251.5. So you can use this one, use trigonometry to find the angle. Or if you don't want to calculate, what is another approach to measure the angle? Lim Yuan King. Lim, are you there? No. Anas, are you there?
Yes, doctor.
Beside trigonometry that I discussed previously, what is another method? A simple method to measure theta 1, theta 2, and theta 3.
I don't quite remember.
Not sure. Have you seen this ruler? Have you seen
Yes,
this
doctor.
ruler?
Yes.
What is the name of this ruler?
I remember it in high school.
You don't remember? You always forget. Astaghfirullah. Game. Protector. Am I right?
Yes, doctor.
You must make sure in your pencil case you have this protector.
Right.
It's very fast compared to the calculation, right?
Yes, doctor.
Measure the angle 180. This is positive because of the zeros. And this one is negative because of the poles. Can. So you total up, you get minus 180, which is plus minus 180, satisfied the rule locus plot. And therefore, you can, this angle is actually on the root locus. Okay. Is there any plot? There. This is the plot. Okay. This is the minus 3. Okay. This is your minus 2. This is your minus 2. Minus J3. This is your minus 2 plus J3. So you can see that the plotting is here. Okay, ended at zeros. And the other one is ended at infinity. Okay. And the length, as I told you before, is you can use this one, S plus 2 plus J3, S plus 2 minus J3 over S plus 2. Then you insert S with minus 3. You insert inside this, and inshallah, you will get the answer K equal to 10, which is equal using the trigonometry approach. Okay, so which one you want to use? Using L or using the magnitude is up to you. Okay, is freedom to choose which method that you suit to you. The second example is the example 2. It's more complicated where you have this. Right. This is the open loop course. Okay. Amirul Mirza. Amirul Mirza. Are you there?
Ya, doktor.
Tidur ke?
Tak adalah, baru bangun juga. Betul.
Bangun eh? Maksudnya. Open loop zeros. Amirul?
Negatif tu.
Ni kena pakai calculator. Ropes ni. Minus 1 plus minus G 4. Betul. Open loop poles minus 10
-10 -3.
A3. Well,
Yes.
to check whether -9 is on the root locus, and if it is on the root locus, find the gain k. Again, same question lah, but different transfer function. So this is the open loop transfer function. This is your open loop zeros, open loop poles, plot on the S-plane. So now you have something like this. Okay, 3 open loop zeros and 3 open loop poles. So use the angle criteria. Okay, angle criteria. So you have to measure lah, the angle. Angle criteria, which is theta 1 plus theta 2 plus theta 3 minus theta 3, 4, theta 5 plus theta 6. Okay, this one because of 0 and this one because of the pole. Okay, and it is 180 degrees confirmed. Okay, and gain is 0.61. Okay, there you go. Okay, using a computer simulations, so you get the -9 is on the root locus. Okay, -9 here. You also can check with computer. No need to do calculation lah. So just insert the value -9, insert the gain, the transfer function, then use the theta formula 180 divided by pi. Pi is 3.14. Okay, multiply angle G. Okay, so angle G, then find the magnitude and find the gain. So the answer is -9. G is -6.22, theta 180. This is important because it satisfies the angle criteria. Then find the magnitude, which is the modulus of G, and then the gain K is 1/m, which is 0.161. Some tutorial for you to test, okay, your understanding. You can use a computer. Use computer lah. Boleh? Use computer and share with me, WhatsApp to me if you done it personally. Okay, WhatsApp to me for the answer using this computer program. Can or not? Hello.
Okay, boleh.
But you must start with this lah. At double prompt, you have to define. TF is equal to S. Is it you have to define? No need, no need. Because you just use this formula, this coding. Okay. If you theta is not equal to 180, meaning that it's not satisfied lah. So no need to proceed for gain calculation. Okay. So there's an answer here. Okay. -3 on root locus, -5 not on the root locus. Yeah. Okay, this one not on the root locus, this one on the root locus. Okay, so this one -4, this one not on the root locus, this one on the root locus. Okay, which is here. Okay, and again at -4 is as shown in the slides. So we stop here, slide 39. So next week, you want to have a class or not? Because Monday is holiday. You want to cuti or you want to have a class? If you don't have the class, you lose 2 hours. Hello.
Uh,
The share.
Online, it's online, it's not face to face because you already have a break on Saturday, then Sunday, then Monday another break. So you will lose a lot, lah, 2 hours. I can do the class if you want, but if majority don't want to have the class, so I cannot say anything.
Doctor, can you make a poll in WhatsApp and see the majority voting?
Can you create it? Can you create it?
Okay.
You
Okay,
create
no
it and
problem.
then you share. Then
Okay.
yeah. So you create the poll and then choose proceed class, not proceed class, and then the third one, no idea. 50-50. Okay.
Okay.
Can you do that? Help me.
Okay. I'll do.
What is your name?
Abu Bakr.
Abu
Abu
Bakar.
Bakr Alimi.
You from Sudan?
Yes.
Oh, Sudan. Okay, wait. I generate the what is this? Attendance.
Mm,
Wait.
Okay.
You launch it today lah, after the class if you have time. Attendance section 11. Make sure your section is correct. This is section 11. Section 11 can scan. And section 12. Okay, can you scan your attendance? Is there any problem?
no, Doctor. Okay.
Yeah. Any question?
Doctor, you didn't put the attendance for section 11.
I already put there, section 11. Can you see? Section 11 at the top. Section 12 at the bottom.
Where?
What's your name?
Anas.
Are you in the list? WhatsApp list?
No.
Oh, no wonder lah. You are not in the list. WhatsApp to me now, your number. You WhatsApp me so that I can add you.
Okay. I'll
WhatsApp.
send you write my number.
No, you WhatsApp me first so that I can add you.
Okay. I got the link already.
Huh?
I got the link.
Okay. You got the link. So you already in the group,
Yes.
but you need to WhatsApp me so that I can forward you the QR. Can?
Okay. What's your number?
Yeah, lah, you just scan from here lah. Wait Section 11 11 Anas. Anas.
Yes.
Section 11.
Yes.
Wait. Can you see? Section 11.
Yes.
Can you scan? Okay?
Okay.
Okay. Have fun. Any question before we dismiss?
No question, Doctor.
Okay, there's no question. Have a nice weekend. See you next week, either Monday or Friday. Okay. Thank you very much. Do the poll option, undi,
Okay.
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 Anas
Thank you, Doctor.
Bakar will do it and help me. Thank you.
Thank you,
Thank you,
Doctor.
Doctor. Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.